Here we have a question that involves a probability distribution, and our first task is to determine what sort of probability distribution it is. Now, the die is rolled 3 times, so we've got n is equal to 3, and the number of times a 6 is rolled is noted. So we're only interested whether it's 6 or not a 6. So there's only 2 outcomes here. So this is going to be binomial. And the probability of success, and a success is regarded as throwing a 6, will be equal to 1 on 6. And the probability of a failure is 1 minus that. Or if you think of a die, there are 5 opportunities for not a 6. So we've got to draw up a probability distribution table. And we've got what are all the different possibilities. So if we're rolling this die 3 times, you could get 0, 1, 2, 3, 4, 5, 6. So it'll be 0, 1, 2, 3, 1, 2, we're not rolling it 6 times, only 3 times. So 0, 1, 2, 3. Now, maybe worthwhile putting in a intermediate line, so this will be probability x equals xi. Now the probability of 0 successes will be NCR. So the general rule for R successes is NCR P to the R Q to the N minus R. So that's for probability of R successes. This was covered previous. So it's NCR, P to the R, Q to the N minus R. So 0 successes, N is 3, so we want 0 successes, so it'll be 3C0. P is equal to 1/6 to 0, 5 on 6 to the power of 3. So 0 successes is 3 failures, and that's 5 on 6. Now 330 is just equal to 1. 1/6 of 0 is equal to 1, so that'll be just 5 on 6 to the power of 3, which is 125 over 216. Okay, 1 success will be 3C1. 1/6 is the probability of 1 success, so we've got 1/6 to the power 1, and if these are going up by a power, the 5/6 are going down by a power, because this number plus this number must equal to that number. So 3C1 is 3, so it'll be 3 times, now this is 6 to the power 2 and this is 6 to the power 1, so that's all 6 to the power 3, so they're all going to be over 6 to the power 3, which is 216. 3C1 is 3 times 5 squared is 25, so 3 times 25 is 75. Going further, we've got 3, so that's 0 successes, 1 success, this will be 3C2, 1/6 the power of 2, 2 successes, and if we've got 2 successes, we must have 1 failure. 3C2 is the same as 3C1, which we determined was 3. So that'll be 3. The denominator, once again, is going to be 216. 1 to the power of 2 is just 1, so that'll be 5. So 3 times 5 is 15. And 3 6s will be 3C3, 1 on 6 power of 3, and if we have 3 successes, we must have 0 failures. So that's going to be equal to 1. 3C3 is the same as 3C0, which is equal to 1. So we've just got 1 on 6 to the power of 3. So 1 to the power of 3 over 3 to the power of 3. 3 to the power of 3 is 216. So this is the probability distribution. When we add them up, hopefully we're going to get 1. So 125 plus 75 is 200. 215, 216 on 216 is indeed equal to 1. So we've drawn up the probability distribution for the experiment. This is 0 sixes, 1 6, 2 sixes and 3 sixes. Okay, now the second part of the question was to calculate the mean and the standard deviation. So going back to the theory we've done before, the mean, which we denote by x bar, is just equal to NP. P being the probability, so probability of success, usually you've got a capital P there, is that, and probability of failure we put with a lowercase q, so that's probability of failure. So the mean is n times p. Now n is equal to 3 times p is the probability of success, which is 1 on 6, and that's equal to cancels down to a half. Doesn't mean too much. So the probability of a failure, the variance is equal to NPQ, is equal to 3 times P being probability of its success is 1 on 6 times probability of failure, which is 5 on 6. So that's 15 on 6 squared, 36. So that's the variance. We were asked for the standard deviation. So the standard deviation, square root of the variance, is the square root of 15 over the square root of 36. So root 15 over 6 is the standard deviation. Okay, so we've gone through an example of a binomial distribution. We've firstly determined what n, p and q are. We use the general rule for calculating R successes. So here R is equal to 0, 0 success, 1 success, 2 success, 3 successes. That's NCR, P to the R, Q to the N minus R, and we apply that rule, do the evaluation, the calculation. We work out for a binomial, and this only happens for a binomial, the mean is equal to N, the number of trials, times P, the probability of success, which is equal to 1 on 2, and the variance is equal to NPQ, and then the standard deviation, square root of the variance.